Okay, Cup. So welcome to the second half of the Bitcoin and blockchain lecture today. We are actually going to go under the hood, so to speak. Now, I did mention that, in fact, a very good explanation is given by this, I think, there. This is a 3 blue, 1 brown video that explains how Bitcoin works, okay, from the beginning to the end. But so basically, let's count the stories, how it works. So how does Bitcoin work? Okay, so you have to remember, recall that money is not just result of transaction, but a memory of that. Okay, so this is it. Okay, so the first idea is money is not money. Money is equal to ledger. Money, concept 1. So this is concept 1. Okay. So how does Bitcoin work? So let's go in 1. Money is equal to ledger. Okay. All historical. Okay. So that's number 1. That's concept number 1. Money is now equates to, okay. Money equates to. So let's have internet allows global share ledger. Okay, let's call that ledger. Okay, so internet allows globally share ledger. What does ledger look like? Okay, so let's look at each ledger. List of transaction. Okay, list of transaction. Yeah. Now, list of transaction. So if A pays B, if A pays B, right? There has to be a. So this is an event. A pays B. 20 units. Okay. So I'm just gonna give some kind of this. Okay. Just think of it as generic dollar. It's not a real dollar. Okay. So this is Bitcoin dollar. So maybe yeah, just use this. Okay, A's pay B this much, $20. Okay, so this is how a broadcast. This is a line that's broadcast to everybody. Okay, so this gets broadcasted. It's just gets broadcast. Okay, so all you have to do to once must verify and make immutable this list. Okay. Yeah, must verify and makes immutable this list. Okay. So this is done by what's called cryptographic hashing. It's done by cryptographic hashing. In other words, what's cryptographic hashing? And let's just go to site. Remember notion of function. Okay, so there's function f of x, y equal to f of x. Okay, some function not invertible. Okay. So in other words, cannot. Let's say some function invertible, i.e. x equals f minus 1 of y. Okay, not invertible, i.e. cannot find x for any y. Okay, hashing is an invertible function. Hashing is an invertible function. So that's hashing. Except x is not a number, but a text piece of text. Okay, and y is not a number, but another piece. 256. I'm just gonna write this word. Okay, it doesn't have to be, but it's some number. I'll show you how it works. Okay, so let's take a piece of text. Let's take a piece of text. Let's go to here. Okay, so this is a very famous piece of text that soliloquy, right? To be or not to be, that's the question. That's the question, right? This is a text. Okay, that's the text. Now, I'm going to take this as my y. Okay. And this is my function. Okay. So that's my x. That's my x. Okay. So my x is equal to soliloquy. Okay. Right. X is equal to, okay. Y is equal to hash x. Oh, that's soliloquy. Now this is just some parameter. This is to say that this is the algorithm I use, and this is how you want to look like. But basically, it's a function. It's basically this. Basically this. Okay. Except, well, yeah, let's just use this, the default function. So this is a little bit fancier than that because, oops, it gets you this number. Okay. So this is important. This is what's called a 256-bit word. It's some kind of weird number. Now, what's interesting is, okay, when you look at this function, I can take any text. Hello. Okay. Hello is much shorter than this, right? So it doesn't matter how long. Okay. It doesn't matter how long. It's going to give you the fixed length. So this is very important. And a piece of length of arbitrary length. Okay. So that's obvious, right? That's obvious. So what's good about it is instead of doing this, okay, I put down A pays B $20, and I get this. Now, okay, let's make it more than one transaction. Then B pays C 10. Okay. Okay. What is important about hashing function is this. Once this is done, it's immutable. Remember the word immutable? Let's say I want to verify, if I want to cheat a little bit, I want B to pay C 15 because I am C, I'm cheating. Look what happened. The hash is irrecognizably different from this. And that is the key property of the cryptographic hash function. So cryptographic hashing is such that except okay. Moreover, if you change x just a tiny bit, a wee bit, y changes a whole lot. Okay. In fact, if you don't believe me, remember this soliloquy, right? This soliloquy is okay. So this is Shakespeare's soliloquy, right? I had to memorize this for one of the sort of like stage play I did. so I might as well make you suffer because I had to suffer, right? So I had to memorize this. But let's say I memorize it. So this is the result, right? This is the result. So let's save this. Okay. So I got this. Now let's say I just make something error to be or not to be. That is the question A. So okay, so I just a little word difference. Say I make this. Yeah. So make this soliloquy true. So it just different by this. Just a little sign. Okay. And let's see what happened. Oops. Soliloquy 2. B. Okay. So A is a soliloquy, and well, I don't really need to do that. See that? Just by changing a tiny bit of thing, just a tiny, very inconceivable difference. Maybe I said about, is it a question or it's a question? Okay. This is entirely different. Okay. And of course, it's invertible. So if I get this, I don't get this. I cannot undo this. So the whole idea of doing this is not to get the information. I don't have the information, but to freeze the information. Okay. So this makes it immutable because you cannot change it. Okay. Once you hash it, to get the same hash, you have to get exactly same value. So if somebody tamper with it, so to make things immutable, another word for immutable is tamper proof. Nobody can mess with it. Okay, so that's what it does. So by putting this, okay, A pay B, and then B pays C, $10 cannot be changed. Okay, cannot be changed. So once we agree on a hash, you cannot tamper with it. Now the question is, how do you agree on a hash? How do you agree on a hash? Okay. But which cryptographic hashing? Okay. So in other words, I can do this, or I can put something else. Okay. So once the payment gets sort of like broadcasted, somehow it has to be frozen. But who gets to freeze it? Okay. So if, okay, same mechanism, if a central bank, okay, were to be assigned the role, this role, okay, who will do the cryptographic hashing of the list. Now, the list, by the way, now is called a ledger, right? Who will now do this? The idea is, if the central bank were to do this, then it becomes a centralized, right? Then we're back to ground zero. We're back to here, centralized monetary system, which allowed the United States Federal Reserve to print money, which again got Satoshi Nakamoto mad. Okay, so that's not what he wants. So he wants this to be decentralized. The way to do decentralization is, well, you guessed it, internet competition. Select by internet competition. Okay, select competition. Now, if you have internet competition and you have the judge, and the judge is the Bank of Thailand, then again you have centralized system. So you can't do that. So internet competition, that's judged by computational criteria. Okay, and that criteria is who gets first. Okay. In other words, okay, this is how it works. Okay, this is how it works. So let's say this is a transaction. Okay, so this is a transaction. Okay, and I add to it some kind of token. Okay, token is equal to done by Punjai. Okay, just something like that, right? Right, and then I do this. Hash transaction token. I get this. Okay. Now, if somebody else, let's say done by Kongkan, so I'm just gonna do this. Okay. And by Kongkan, okay. So let's just sign Kongkan. Okay. You see that it's all different, right? So who is supposed to be the one who wins? The one who wins is the one who does this. Again, this is very unpredictable. You don't know what it is. It looks random. Okay, got to write hash function and y looks really random. It's not random because you always get the same value. But it looks real random. Yeah. So this looks very random. Now let's say, okay, let's say that some guy, his name is crypto miner Bob, okay, and he gets this. Except I'm just gonna cheat. Except he does this. He does this, and the result has instead of getting all the funny number, it gets this, okay, of the same length, presumably of the same length. Okay. Whoever does this gets to freeze it. This is like internet competition. Why? Because I can try many times. Trial 1, and I can set trial 2. Right? And I get 1 0. Ooh, great. Okay. But I need to do this gazillion times. So after I do this, let's say done by Punjai trial 5 million. Okay, so I've done 5 million of this. Oops. Okay, this is my trial number 54 million, and I get this. Then this thing is what gets frozen. This guarantees that there is only one. There's only one list. It's just like the Yappies. Everybody agrees in the Yappies community now that A pays B $20, B pays C $10. Nobody disagrees with this. Now, why would I get to do this? Well, it takes me a lot of computational power to do this. So when I do this, I have to get some reward. Okay. So instead of doing this, I get some kind of reward. So instead of, it would be something like this. I add another transaction, right? So this is one transaction, this is another transaction, and add another transaction. That's another section, say, universe pays $1. Okay, I just add this. And let's say I do this. So now I get $1. So this is my motivation. Okay, that's it. So what Satori, the protocol that I was talking about, okay, the computational protocol that he did is precisely that. So this, okay, so who will get this? Who do the handling? Okay, whoever gets so many zero first. Okay, whoever gets a bit of free money, and this is called Bitcoin mining. Okay, so think about it. Bitcoin mining is actually a byproduct. It's the motivation. This is the genius of Mr. Satoshi Nakamoto. Okay, is that he needs this to happen, but you can't just motivate gazillion people all over the world to spend a lot of computational wattage, you know, and electricity bill to do this, right? So this competition has to be rewarding, and this reward is a little bit of free money. So in other words, it's this. Get the transaction. I want to get extra money, and by my trial 54 million, I get this. So this is frozen. This becomes a block. $2.4 frozen ledger is called a block. Okay, it's now a block. It's done. It's done. So now it's like communities of Yappies. Everybody has a common memory of who paid whom. So that's done. It's immutable. It cannot be changed. Okay. How do you start a new block? Well, you do the same thing. You do the same thing, except what's clever is that a new block new block is tied to the old block. New block. How? By putting the hash, this is the hash of the old block in the first line. Okay, so let's say this is my, so I'm just gonna assume that I'm gonna pretend, okay, I'm gonna pretend that this is a lot of zero. Okay, this is a lot of zero. So now I have so let's do this. I'm just gonna make it very transparent. Okay, so This is how I hash the first block. Okay, block one is equal to this. Now I'm going to hash block 2. Okay, I'm going to hash block 2. I'm going to do exactly the same thing, except, okay, I have a new transaction now. So transaction 2 equal to Alice pays Bob $3. Bob pays Chris or in yeah. Okay, so let's do that. That's my second transaction. So what I'm going to do is once again do this. Now, instead of having the transaction 1, which is already frozen, I'm going to freeze transaction number 2. But in order to freeze transaction number 2, I have to put the hash of number 1 first. And let's say this is done by Gong Kan and trial 75 million something. Okay. I'm going to again pretend this is 0. So this is now frozen. This is now frozen. What makes it difficult? What makes it difficult is that it's already difficult to be the first guy who gets all the zeros. Okay. If you're going to fake that 1, you have to come up with another hash that has all the 0. But that is contained in here. So if you're going to fake number 2, you have to fake number 1 and number 2. So you can imagine that if you get to, once you get to something like block 500, okay, to fake this 500, you have to get all these zeros, you know, not just once, which is already a million calculation, but you have to do that 500 times. So in other words, more blocks. This makes subsequent block even more secure than the earlier block. Okay, so doing this, when you tie them together, hence block chain. Hence block chain. That's it. Now, there are many details. There are many details involved in all of this. Okay. In other words, you know, Satoshi Nakamoto said, you know, in the beginning, it's easy to get $1. As computer gets more intelligent, more power, it's not enough to get 6 0. Every 5 years or so, you have to get another 3 0. So this is to take into account the fact that computational power gets stronger and stronger. So that's what happened. So he does it. Okay, so he does it. 2.6 Satoshi. Okay, what did he do? Okay, Satoshi Nakamoto, right, makes the problem competition harder over time as computer gets faster. Yeah, make sure 2 things. A, the competition gets harder over time. Yeah. What else did he do? Actually, B, the reward gets smaller over time. Why is this important? Because if you get $1, okay, $1 plus $1 plus $1 plus $1 plus $1 plus $1, okay, this becomes infinite, right? Now, what happened is, let's say after 5 months, you add 0.5. And after a while, you add 0.25. This becomes, and so on. So while is infinite, okay, this while this is infinite, this is finite. In fact, if you start out with something like, I don't know, 1 or something, there's a mathematical formula for convergence. In fact, he ensured that at the end, the way he figured the mathematics, right? In the end, final supply of Bitcoin is, I forgot, I think it's 21 million, right? Anybody know? What's the final supply of Bitcoin? Yeah, I'm not that interested in. Anybody knows? You guys should know. $21 million. Okay, good. Okay. Basically, this formulation is okay. So Bitcoin. So this is this, but it's not dollar US. It's final supply Bitcoin. Okay. So that's it. It's done. He did this brilliantly. Okay. So how does Bitcoin work? It works very well. Okay. It solves a lot of problems. Okay. It solves the problem. First of all, it makes things very convenient because you're using internet, right? Right now, if you want to pay somebody, you have to go to a bank. You know about the sanction, right? Russian banks, because the government invaded Ukraine, can no longer participate in what's called a SWIFT network. A SWIFT network is a message. It says that somebody from this bank sends some amount of money to somebody else from the other bank from a different country. Okay, but you don't need SWIFT network. If you have Bitcoin, this thing is transmitted on the internet. Okay, so there's no way you can sanction this system of payment because you basically pay over the internet, right? If you sanction the internet, that's something else. But certainly, right? Okay, right now, banks that are not part of SWIFT, you cannot go to that bank and say, I want to send $10 to the United States, because you have to go to a bank that has a SWIFT network. That bank via SWIFT network tells the other bank to deposit $10 to the other guy that you want to pay. And the bank kind of settle the difference between themselves, right? So that's the platform. The message of A in Thailand pays B in the United States is A paid $10 to a bank in Thailand. Bank in Thailand send the SWIFT message to a bank in America of that $10 transaction. That bank paid $10 to B, and then banks in Thailand pays that bank in America $10. Okay, so that you need that SWIFT network. But with Bitcoin, you need the internet. You just need the internet because this is done over the internet. Okay. Moreover, with dollar right now, dollar is pegged to, well, the dollar is basically controlled by the Fed. The Fed can do this anytime. Okay. Now, the last time we kind of said, we kind of understood that the Fed has to do this because of this. Okay. So we kind of turned the blind eye. Okay. It's called quantitative easing. Okay. But what if the United States wanted to do something because the United States has run into debt or whatever, just manipulate some kind of thing. So this is centralized. It's control basically. So that's why this idea is very appealing. It's efficient because it uses the internet, but it's so appealing because there's no central control. Okay, so no central control. So by doing all this, okay, you can't double spend, you can't cheat because you can't change this. Okay, because everybody agrees, right? And the money supply grows. So these two main problems. There are other technology that solve this, but basically that's how block monetary, how Bitcoin works as the money. Okay, it solves these two problems. So to get back to this slides, okay, how to solve this? Okay, that's with the blockchain, right? And how do you make sure that this money grow predictably? Well, by giving a little bit of reward that gets harder over time and gets less over time. So this is how, by controlling this Bitcoin mining reward, okay, it ends up with money growing predictably until I think in I don't know how many years time when will all Bitcoin be mined? Roughly 2040. Okay, so by 2040, so this is whatever amount it is. Okay, forget about how much it's worth in dollar. I'll get to that. How many Bitcoins are there right now? How many Bitcoins are there right now? Right now there are 18 billion. Okay, right now from the beginning, say 2008 to today, 2022, we have 18 billion. We only have about 3 billion left hidden in the computational universe. By 2040, this number, okay, so right now, so let's write that right now. 2003 today, right? Today is 17. As of there are Bitcoin. Okay. By 2040 or thereabout, they're all Bitcoin will have been mined. Okay. So this gets to the question, well, then who's going to do all the blockchain freezing? Well, now there's like a blockchain creation reward or something. So you can do that. You can get around that. Anyway, so that's it. That's it. So this is what Bitcoin and blockchain is. Okay. I really want to sort of like almost stop a lesson here, but I can't, because now we get to this bit. What happened to the society once Bitcoin lands? So let's get to the mind map. I think I turn off the mind map there. Okay. So you know the Bitcoin, what is it? It's a decentralized monetary system. The origin story, I tell you the origin story, okay, by a guy of Satoshi Nakamoto. But I haven't told you the whole thing, which is the fact that this is an alias. So you actually don't know who that guy is, okay? There's some picture of some mathematician here and one in Europe, I think, that you guess, but nobody knows who it is. So it's a very interesting story. How it works under the hood? Blockchain, basically, blockchain. Okay, so you see how it works. Now, so let's think about this. What can it deliver? What's a business use case? Now, I want to go first here. Bitcoin, what can it deliver? Well, it's designed as a monetary system, right? So it delivers what? It delivers a monetary system. It's exactly what it did. It delivers a monetary system, its original idea. What is a monetary system? A monetary system is something that does all this. This is a monetary system. Okay? It's something that does all this. Okay? Except the supply of this money, instead of being controlled centrally by Bank of Thailand in the case of Thai baht, or by the US Fed in the case of dollar, right? It's governed by computational protocol, which cannot be intervened. So you cannot corrupt the system if it's mathematics, basically. You cannot corrupt mathematical function. Okay, you can certainly hack the computer that implements it, but certainly you cannot corrupt the mathematics. Okay, and there are a way of ensuring that it doesn't get corrupted through all this hashing thing. Okay, so this is the power of cryptographic hashing. Now, I'll talk about encryption technology, I think, in another class, but that's something that is on top of this. Okay, it's some other technology set, but it has the same word, cryptography. Okay, so anyway, so this is what you have. This is what it delivers, right? It delivers a monetary system. That's the original idea. Okay, that's the original idea. Right now, okay, now what's the original idea? The original idea is that if we can work with Bitcoin, we don't have to work with dollar. So this is kind of like sort of like an anarchist, sort of like libertarian's dream, utopia. Okay, the Fed is not controlling money. Okay, nobody is controlling the supply of money. Computer is, and that computer is already pre-programmed, so you cannot recode it. So nobody can interfere. So at the end of the 2040, there will be 21 million Bitcoin that serve as money. And all the price of goods in the world is priced relative to this. Okay. Now the numbers can get big, you know, so you get something like a cup of coffee is worth 0.0001734 Bitcoin or something like that. Okay. But you know, if you're working with computer, you don't care really that you have to work with tiny decimal. Okay. So you can say that this cup of coffee is worth a nano Bitcoin or something like that once things get really expensive. Okay. So you can say that. So this is what it is. However, right now, the practical outcome you can hope is a payment platform. Okay, what it means is that it's convenient, right? It is it's green. I'll get to that later. Okay. In fact, you know, paying my bank $10 so that bank, you know, with some whatever a teller keys in, and I drive to the bank or whatever. Okay, and the bank go to the Swift, and Swift go to another bank, and blah blah blah. That's quite a lot of carbon footprint. You know, Bitcoin transaction is relatively inexpensive in carbon footprint. I'll tell you why that's not true, by the way. But let's go with that first. So anyway, it's practical, it's fast, it's incorruptible, right? If you hack a bank, you can actually forge a payment. You cannot hack blockchain, right? So this is more secure. It's a secure platform. It's much better than having a bank to bank. Okay, so it's a practical, very practical outcome. Okay, so the original idea again is Bitcoin comes in and replaces dollar. But of course, what's happening? The actual happening is that nobody treats Bitcoin as money. Nobody does. Bitcoin becomes a speculative asset. Okay, you buy Bitcoin in dollar so that you can sell Bitcoin for dollar, basically. Okay, now if you mine, you're still doing the same thing, except you're doing a little bit more harder way. Instead of paying dollar to get Bitcoin, so that when Bitcoin goes up, you can sell back to get dollar. You pay dollar to buy computer to mine Bitcoin. Okay, so you convert dollar to computer, you convert computer to Bitcoin, and then once you compete, Bitcoin rises in value, you can convert back to dollar. Okay, so essentially, you still have the same monetary system as before. Okay, except that's why you get this chart. Okay, that's why you get this chart. Bitcoin price. That's why you get this chart, right? If you look at this chart, it has an axis. This is price of Bitcoin relative to something. Now, this could be dollar, this could be gold, this could be Thai baht. I don't care. It doesn't really matter. The point is that nobody really is treating Bitcoin like Bitcoin. Okay. When was if you go to if you take an internet survey of everybody in Thailand, okay, say how many people? Let's ask. Okay, I can ask you actually. How many of you are in Bitcoin space? In other words, you hold some Bitcoin, and you will say something like lots. How many of you bought a coffee in Bitcoin? Okay, I would bet none. Okay, in fact, I have friends who are actually into Bitcoin mining and relatively successful through some algorithm. But if I ask the same question, have you ever bought any coffee with Bitcoin? You say none. Okay, so it's not serving the original purpose. Is that good or bad? So let's go to this question. Okay, so this is kind of what's happening. Is good or bad? Well, let's see. Okay, so now, okay, is it good or bad? Well, there's a debate right now. There's a debate right now on what's called it's if you look up things under things like Bitcoin is carbon footprint. It's terrible. It's quite bad. Now, some of the study have exaggerated a little bit. For example, there's a well-known study that most people quote, but that study sort of like assumed that Bitcoin mining technologies doesn't improve, right? The computer is slow, but you're just doing more of it, and it just makes all kind of assumption that makes it very, very carbon intensive. What I mean by carbon intensive, that means that to mine the Bitcoin, to do this thing, right? Gazillion time takes a lot of computer. Yeah, doing this gazillion time takes a lot of computer to do this. Okay, in fact, remember I told you that remember this is one of those things where let me just recall how convolutional neural network only possible with GPU game card. Okay, same thing with Bitcoin mining, except much more power consumption. Think about it. When I do this, I train the neural network it runs for hours. For example, I told you, right, this thing, there's a language model that's done by, let's go to the internet. Okay, Wangjanberta. Okay, and let's say how long training time. We'll find it somewhere. But anyway, the point is they use computer, with GPU worth 200,000 baht and 5 of them, and they ran for God knows how long, 5 months, I think. Okay, they ran this thing for 5 months, so it's very computationally intensive. But you only need it to do once. Once you have it, it's pre-trained. Okay, so let's call it deep learning. i.e., Wangjan is very computational intensive to train. But once trained, you can use it on your laptop. Okay, once trained, not by you, by this tech. Once trained, anyone, you can use it. Okay? So this is a sort of like, this thing is computationally intensive, but you just do it once. Whereas this thing, okay, Bitcoin mining is much more power consumption. Not because the algorithm is power consuming, it's because you have to do it gazillion times, and there are gazillion people doing it. There are gazillion Bitcoin miners doing gazillion of calculation each second. Okay, so that's it. That's the difference. So yes, some crypto carbon footprint scare is exaggerated. But no matter how you calibrate the estimation, crypto is bad for the environment. It's bad. No matter what, it is bad. Okay? It is bad. Now, some people will agree. So you can say some people would say that if you kill all bankers and use Bitcoin, there would be dramatic reduction in CO2 emission overall. Yes, that's true. That's definitely true. Okay, if you replace dollar, Thai baht, yen, euro, everything with Bitcoin, yes. But that means, you kill all the banks, all the bankers, everything. But that's not really that's not really, that's out of the question. Okay, so you can, some people would argue. Yeah. So yeah, the long and short of it is bad. Definitely bad. Okay, there's some over exaggeration, I admit to that, but yeah, overall it is bad. So Bitcoin, if it doesn't do anything, right? And right now, it's not doing anything. All the Bitcoin mining, all the Bitcoin trading is speculation. Except there's a big difference, right? I don't know if you can speculate on something stupid. Let's speculate on something like something really stupid. Let's say I'm speculating on the value of okay, here's a good one. Okay, speculative market for designer basketball shoes. Okay, so this is a speculative market. Okay, this is speculative market, right? Now, if I take the price, there's no graph unfortunately, but let's say I have this graph, okay, and it looks just like Bitcoin. It is speculative asset, right? Except what is the footprint of this? It's the footprint of manufacturing a pair of shoes. Okay, so if you speculate on anything, it's a speculative asset. That's all the value it adds to the economy. Okay, somebody with fairly efficient algorithm can maybe mine some pattern and get some money. And if you leverage that, you can do Bitcoin trading. Well, you can do the same thing. Okay, you don't have to do Bitcoin trading. Okay, you can do, you know, why, you know. So let's say, why do Bitcoin trading okay, which is speculation, if you could say, and again, do Nike, Air Jordan trading or something. I don't know. I don't care. I'm not into that space. Okay. So I don't know what's the hot shoes now. Nike, just some kind of Nike. Okay. Nike trading, right? Nike. Yeah, just put casual, just sumo. Okay. Right. Exact same thing. If there's a market for this, it doesn't make you any more technologically advanced. Okay. In fact, it makes you less technologically advanced. Why? Because this one is already coded in the market. So all you have to do is download the time series, right? Whereas if you're going to do Nike Air trading, you have to do a little bit more data scraping. So it's a little bit harder actually. Okay. So this is no more technologically advanced. Okay. You could do this. You can speculate on Rolex, secondhand Rolex. Secondhand Rolex. I don't know why you would do that. It's kind of stupid, but yeah, you certainly can do that, right? And people do make money from it. Okay, so Bitcoin is fundamentally no different from this. Okay, the only difference is that instead of doing the trading from zero, you can actually do some mining, and that again is the problem is, think of the carbon. It's very sad, actually. It's a very sad story. Okay. So I don't want to end on a sad note, do I? I don't want to end on that note. So how will, okay, so let's so Bitcoin, again, decentralized governance. Again, this is the original concept, right? Did it happen? Did it happen? Oops. And this is a sad story of, again, Satoru Nakamoto comes from a history of what's called libertarianism, meaning that you don't want government to do things for you. And the backstory of libertarianism is because, you know, in the in medieval Europe anyway, in medieval Europe, you have tyranny that's tax. And when the European kings and queens tax, that's sort of like, you know, forget about printing money, just basically takes money from the farmer because they want to fight war. Basically, you know, they do it to dress up Versailles and you know, whatever, Buckingham Palace. Yeah, they certainly dress up their palace, very elaborate, and European monarchs are known for elaborate palace. But I would argue that the reason that they tax their farmer and their people heavily is not because they want a fancy house. Mostly it's because they're doing war, they're fighting. Okay, most of the time you have this you know, the King of England wants to raise a tax or whatever. It's not because he needs a bigger palace. That usually has enough money to do that, but it's usually to fight war with France, that sort of thing. Okay, so from that you have this seed of libertarianism saying, you know, if the government can reach into your pocket, so instead of like a king going to the of England or king of France waging war, it could be United States government increasing tax. Okay, so this thing about taxing, about money, about Fed, about this and all that, this is sort of like gave rise to kind of libertarianism, saying, well, we should have decentralized government, or decentralized governance. So that's the dream, but that hasn't really evolved, has it? What happened? What did we actually get from decentralized governance? We actually got instead that dark economy. Remember I told you about sanction, right? Well, sanction has to pass through legit channel. When I pay somebody's money to the United States, right? That person has to have a bank account in the United States. I can't use this to send money from buying drugs because it has to be legit business. It has to be, you know, so when you have something that doesn't go through the formal channel, what do people use it for? For efficiency? No. They use it to buy guns and human trafficking and drug trafficking and all kind of things. So instead got dark economy. Yeah, it's got that instead. So that's no good. That's not good. And in fact, it accelerated surplus to superfluous. And I'll talk to you at length, perhaps in some other context. But this what happened when, you know what an economic surplus is, right? Well, we didn't have surplus back then because whatever food we gather in the morning, we ate in the afternoon. Well, when the agriculture became part of society, you can grow food in the morning, keeps it, and eat it a year after because you can store grain, right? So you start to have surplus. You have things like free time. You don't have to hunt for food in the morning to eat. You can eat off of things that you accumulated. So you have free time. So what do? You create art, you create music, society grew. So it becomes something that's not food related. Okay, it becomes art, science. Well, at some point, it gets beyond art and science. It becomes superfluous. Okay, so now we have professional meme creator, right? You're not making food. You're not creating science. You are creating internet memes and sell it. You're creating TikToks and sell it. And you can literally make money from that. So this kind of accelerates the surplus to and this is the theme, right? That every generation turns the previous generation surplus, which is a good thing, into superfluous. That happens every generation. That happens. I'm not blaming your generation. My generation did exactly the same thing, okay, with different things. But this cycle, is it more accelerated with Bitcoin? You can say that, well, it's not really part of Bitcoin, but certainly you have to watch for it. And I think Bitcoin certainly makes it easier. If you think about it, what's the story? What is the most surplus to superfluous poster child story? Anybody can think of right now. What's more superfluous than trading Bitcoin? What's more superfluous than trading Air Jordan. What's more superfluous than trading second-hand Rolex? Anybody? Well, how about NFT? Right? So certainly we have all this kind of silly superfluous speculation before. I told you that we had this since the Dutch in the 15th century speculated on the price of orchid bulb, right? Not orchid, sorry, tulip, not orchid, the tulip mania, right? Of like 15th century, right? 15th, 16th century. So we had superfluous speculation before, but now, sure, think NFT, non-fungible token. Fungible tokens. Now, you can literally buy non-fungible token with dollar, with real money if you like. But then again, you know, that's not how the market was created, and that's not how the market magnified. And in fact, because of all the superfluous speculation we got with Bitcoin, what do? Well, you have to launder, well, not launder, you have to park your asset. Okay. This is why you know that, right? You know that when the Soviet economy, Soviet Russia dissolved into a quote unquote capital economy, what happened was the state basically, what they did was they sold off, you know, and this is a little bit of politics, but what in the name of quote unquote free market economy, the state asset like oil, franchise, all this gets quote unquote privatized. And that's why you have these Russian oligarchs, and they get so much money, they don't know what to do with it. They can't buy Russian assets. There isn't so much to buy. That's why most of expensive properties in London are owned by Russians. Okay, it used to be the same thing with Japanese and Canadian buying expensive real estate in Manhattan. But now you have these Russian oligarchs buying a lot of very expensive. So you're talking about this sanction, right? This kind of trying to seize the oligarchs' yacht. Well, yacht is a little bit easy to seize because you can kind of spot it. But in London, you can't spot them because of certain law that allows foreigner, principally again Russian oligarch, to buy London property anonymously. So that's what happens, right? That's what happens. So all this quote unquote free market economy, liberalization, you know, people will say, oh yeah, government is not efficient, so they go all the way to the extreme. They privatize everything. Well, the result of the privatization is that state asset becomes individual assets. And so all this, you wonder why all the Russian oligarchs are rich, because they basically got Russia's wealth, Soviet Russia's wealth. Not much, that's not much, but when you divide it by about 50 to 100 oligarchs, that's a lot of money. That's a lot of money. Okay, so yeah, Soviet Russia wasn't rich, but it certainly has a lot of resources like oil and gas and so forth, right? Well, if you divide all that among 50 or 100 people in the name of liberalization or free market efficiency, you hear that a lot when people try to privatize. They get a lot of money, they don't know what to do with it, they park it. Exact same story happened with Bitcoin. People who speculated on Bitcoin got so much, they have to park it somewhere, and that's why non-fungible tokens are that, you know, you ask people why, it's silly, right? You buying non-fungible token, the right to own a digital asset that anybody can just look at. Well, that's missing the point. Okay, people who buy expensive hypercar to launder money, they don't drive them. Most of them might not even like cars, but they buy to launder money. Okay, it's the same story. Okay, so you can think of it as not by money laundering, but sort of like parking excess speculation profit in NFT. Okay, so that's what happened. So it's very sad because, why is it very sad? It's very sad because of this, and I'm going back to this. Okay? Going back to this. Yeah, And in particular, this. The Bitcoin, well, forget, I'm not going to Bitcoin yet. I'm just a bit, I'm not going to blockchain yet, just Bitcoin and cryptocurrency has potential to do all this. But because we got greedy, we get hung up, not on actual investment, but speculative investment. There's a difference. Investment in productivity, but investment in speculation. It's very hard, difficult line to draw legally, but in terms of data, in terms of phenomena, it's very easy to speculate. This is investment. I'm buying a factory because I want to produce something versus I'm buying something because I want the price to go up in 5 months' time and sell it for profit. Okay, so speculative investment and genuine investment is very easy to identify which is which. Even though legally it's very difficult to do so, you can tell. Okay, this is the guy is buying expensive exotic car because he loves it, or he's doing it because he's laundering money. It's very easy to say. Yeah, you just can't prove it. Same thing here. That's what's happening. But it has potential to do a lot more. Okay. In fact, this is where we get to Ethereum. Now, Ethereum is a little bit even better than blockchain. I don't have the slides on that yet. Okay, let's finish off with this slide. So this is so this is how bad. Okay. Now, so this is kind of side function technical. Now, okay, so let's get to this. Back to money. Now, money as financial instrument. So with money, you have all financial instruments. What are financial instruments? Okay, if you buy insurance, it's a financial instrument. What does it do? Financial instrument that spread your event risk around, right? What's your event risk? Car crash, right? Business warehouse burns down, right? War, right? COVID, okay? Those are event risks. Okay, this is what money as financial instrument allows you to do. So things like what else? Kind of risk management, all kind of stuff. Okay, so something like, okay, how about store? You can think of a wealth, assurance, pension. Okay, so make sure that when you are old, you have some money. Make sure that you are still your children have education, right? So all kind of stuff. These are done by insurance policy. These are all financial instruments. Now, to make this, it has to basically financial assets, financial instrument in a way is equal to money plus legal contract, right? So the legal contract, for example, say I pay you 10,000 baht this year, so that when my car crash, you pay for the fixing. Okay, so okay, so finance. So now, if Bitcoin money, you just need Bitcoin crypto financial Bitcoin or crypto. And by the way, I'm using generic now, right? Bitcoin could be Dogecoin, whatever. Bitcoin is money. So let's say cryptocurrency, money plus, okay, some code. Now, this code could be something like coding equal to Ethereum smart contract. So you start with cryptocurrency. So, oops, sorry. Let's do this. Smart contract equal to money, but crypto currency plus programming code like Solidity. Wow, what programming code? Yeah. Example. Okay, Ethereum. Now, how do you program Ethereum? And I don't know how to, but I think maybe we have a class where you could have a little. I was hoping to invite maybe big cup people, maybe if they know. I don't know if they do Ethereum or they're just speculating. I don't know. Okay, I'll talk to them for programming Ethereum with Solidity, I think. So yeah, we'll have something like this, maybe Ethereum for Java developer. I think it's Solidity. So Solidity, I don't know if there's a special sign or no, no special sign. Now, for example, okay. So for example, I can do something like if 2030, okay, global average, global temperature is greater than 2.1 degree above pre-industrial. Where are we now? Anybody? A is B 1 Bitcoin. Okay. Now, what's nice about this? Okay. If on, okay. So that's it. That's a bit like risk management, right? Now I'm making the example interesting because I could make example like car crash, but this is more interesting. What this code would do in Ethereum is say on the date, okay, so Ethereum is programming on the date. What it would do, it would look up global temperature estimate. So maybe some kind of reference. Okay, so maybe there's a website like IPCC, International Planet or Climate Change, reference IPCC.org. IPCC. No, IPCC. CH. Okay. So this algorithm is going to go to this website. Okay. Look up for global temperature. Okay. And see this value. Okay. Right now, I think global temperature, what I think it's 1.4 if I'm not mistaken. Anybody? Global temperature 2000 above pre-industrial level is around about 1.2, let's say. Okay, so 2 is a terrible number. Yeah, so maybe that society would collapse by then. So let's say something like 1.7. That's terrible already. That's near collapse already. Okay, so I don't know how much 1 million Bitcoin worth of happiness you will get at that time. So something like that. So this has not taken off. This has not taken off. Instead, what do people use Ethereum for? Anybody? You guessed it. Instead, people just speculate on Ethereum. Just like they do on Bitcoin. That's a very sad story. So it's very promising, something that is so intelligently engineered. So ends up being something rather silly just because people want to make quick buck. Huh? Okay. Right. So I think I've got what I've wanted to say for today. Next week when we come back, I will go over a little bit of the sort of like cryptography, and that's kind of related, but not quite the same aspect. Okay, not same aspect. I prepare for you already, like public encryption and all that stuff. So that's this thing. Play with it, cryptographic hash, and then yeah, we'll have that for next time. Where's the code? Okay, I haven't said it. Okay. Right. So again, what have we done today? Okay. I try to trace the original spirit of money. Okay, math and money. That's what it's all about, math and money. Okay, and the invention of blockchain that really drives Bitcoin, and the smart contract that is sort of like Bitcoin 2.0 and Ethereum. And again, the disappointment is that now you just think of Ethereum. If you ask and garden variety Bitcoin or crypto traders, what's the difference between Bitcoin and Ethereum? They'll probably give you something that has to do with like, speculation value. Like, well, this one holds value well. This one doesn't hold value very well. This one is like, has a lot of volume and blah, blah, blah. It's all just about speculative characteristics. Okay. Very little about what Ethereum can do as a financial instrument. And that's because Bitcoin has done very little as money. Okay? So anyway, I traced that, by the concept of money. By the way, this is supposed to be one of the guy that people thought was Satoshi Nakamoto, but he said no, it's not him. And there's another European guy somewhere, I think. I don't know, Irish or whatever. Okay, so money does this. Money does this. Centralized money does this by controlling the supply of money with respect to some rule of law, some mandate, some central bank policy, right? So after and the concept of money, again, this is all about concept of money as memory. So it's all summarized here. Oops. Where is it? The whole thing I talk about is this. Money is memory. Okay, money is memory. Now, so to engineer Bitcoin, how do you solve that? You have to solve two things: solve the double spending. Okay, and that's the concept of blockchain, and that's how it came about. And Bitcoin of mining solved two problems. It creates blockchain, and while it's creating blockchain, people who create blockchain gets reward, and that's how monetary supply grows. So it's very ingenious between these two pages. There are other technological, mathematical, computational solutions required to make Bitcoin ecology work, ecosystem work, ecology, to make cryptocurrency ecosystem work. But basically, these are the two breakthroughs. Okay? So that made it possible, but people just ended up speculation. It's quite sad. Yeah. It's quite sad, and not only that, it uses a lot of resource. So if all you want in life is do algorithmic speculation, why do it on Bitcoin? Why not do it on secondhand Rolex or Air Jordan or whatever? That has a lot less carbon footprint. Okay. So this is this is a symbol of Ethereum, and it put in the slides. Okay. So I think with that, oh, good, we have 10 minutes left. And I want to show you that the resource, okay, sorry, the resource part, yeah, go here to slides, oops, where are we? Okay, so go to the URL for this class. Oops. So go to the URL for this class. Class 9, right? There is a math of Bitcoin and blockchain. Okay, so go to that. And yeah, how does Bitcoin actually work? And this is the one by 3 blue, 1 brown. That's this one. And that's the one that actually I sent to you before. Okay, and this one is worth watching several times. Okay, there 30 minutes there is much better than I could do in 30 minutes here. Okay, there's not even a close compare. And this is another one that's good, but this is a bit more for next class. Okay, it's about public key cryptography. So this one and maybe this one, these two are basically for next class. The carbon footprint debates, go read that. There's I guess the paper that gets quoted a lot was 2018, and there's some counter argument, but you can go to here. I think this is a more recent calculation that takes into account. There are online resource that does this kind of Bitcoin energy consumption, and you have to look into detail on which methodology this is based on. And just to make drive the point home, it actually shows energy consumption by country. Where's Thailand? Thailand's about 200, I think. Yeah, Thailand. Oh, it's very clever. It knows we're in Thailand. Thailand's about 200 terawatt hour. I think as of last year or whatever, may have gone down a little bit with COVID. But certainly, Yeah, this number, no matter how exaggerated it is a big number. Okay, so maybe lower estimate would have it like 10 metric ton or 50, but it's still a big number. Okay. Same thing with electron energy, right? So if it's 200, it's almost like Thailand, right? But if this is a high estimate, maybe lower estimate is like half of Thailand, just for Bitcoin mining. Okay. By the way, Bitcoin mining is not doing anything. It's just creating speculative goods, like producing Nike Air Jordan or second-hand Rolex. Not even first-hand Rolex, I think, right? So you're spending half of Thailand, maybe about Thailand's worth of energy, just to make something that people speculate. That's really sad. Okay. Now, if you use it to reinvent economy, fine, but that's not what's happening now. That's not what's happening. And this is what's called electronic waste. By the way, electronic waste is one of yeah, it's compared to Thailand. That's good. That's very smart. Okay, so electro engineer compared to Thailand. Oh, okay, so that's why it put Thailand here, not because it knows that I log in from Thai URL. Okay, Thailand's here, Netherlands. So presumably, yeah, if I focus on this, it would show Czech Republic. Okay, electronic waste, by the way, is not talked about very much, but it's a big problem. It has a lot of knock-on effect. Okay, now this is where it gets a little bit controversial, because Bitcoin transaction footprint, this was where the original paper kind of like overstated thing a little bit, because you don't need to do the whole block just for a single transaction, or but in a way it's fair, because for every successful blockchain, there's a lot of missed blockchains. So this number can't really be overestimated that much. So it uses a lot. It's terrible. Okay. So the debate is here. You can go to this is a good site as well. I think Down to Earth. It's I don't follow it regularly, but let's certainly go and read it. All right. This has other things, okay, and talk about NFTs and whatnot. Okay. And it talks about not just Bitcoin, obviously. It talks about other things. But, yep. So something like this, you should be aware, and that's really back to my theme. That my objective here is to teach you about Bitcoin, blockchain, how it works under the hood. But as a Basai student, right? Well, in fact, if you watch enough YouTube, presumably you can even learn that by yourself, I guess. Okay, but Basai is about more than that. You can really, you think about all this. Now, before you came to Basai, you probably had this impression that Basai graduate is just like all about this. Okay, just come in, don't have to own any technology, don't have to own any innovation, but just look at some innovation, have some bright idea, creates an app, makes a lot of money. Okay, so this is a very selfish and very narrow-minded way that sometimes we portray a Basai program, right? The students come in and for 4 years pick up some idea of new technology that they don't really know, because they're not engineers, they're not biologists, they're not chemists, they're not physicists, but they pick up nanotechnology on the way, they pick up data science on the way, even though they don't know anything about machine learning or don't know very little, and just make a business out of it. Well, that would be here, right? That would be here. This question is legit to ask, but it's not the only question you should ask. Okay, you should ask all the way from here to here to here to here. Okay, behind the hype of any, behind the type of emerging tech, any idea. But today, Bitcoin and blockchain, this is our case study. So, I don't sound as quote unquote enthusiastic or as about what's happened to the Bitcoin space. When I was 2013, I really loved Bitcoin. I really love Bitcoin. I love the math. I love the engineering. I love everything about it was so beautiful. It was gorgeous in 2013. Then it started to look like speculative asset. Okay, you don't have to do anything. Just get some electronic wallet, turn your Thai baht into Bitcoin and just watch it grow. Once it got to that point, I completely lost interest. And coming back to it just to give you guys lecture, nothing has progressed from that. Well, aside from NFT, which I don't know if it's progress, but no. Ethereum hasn't taken off as a programmable currency, as a financial risk management tool. Nothing, right? In 2013, I was sort of like, Bitcoin is so good. In the future, I'm gonna write my will to my children in smart contract, right? If my children gets good grades, and you can do that by accessing the GPA report of the university. If my children graduate over 3.5, he or she will be able to unlock 2 million baht worth of Bitcoin immediately, or something like that. This is all programmable in smart contract. But none of that came out. Okay, none of that came out. So it's not a nice story, but it is a lesson. It's a good lesson. It's a brilliant lesson. So with that, I certainly, well, we kind of out of time, but certainly you can ask any question you like, and we can carry this discussion to next week, because I'm going to talk a little bit about crypto encryption technology, right? But I'm not going to spend the whole next session on encryption. Okay? So I want each of you to actually, given that a lot of you are actually thinking about this Bitcoin blockchain space, I want each of you to prepare like a 5-minute discussion, 5 to 10 maybe, okay? Discussion about what you make of Bitcoin and cryptocurrency technology, right? You can espouse the hype, or you can whatever. You can say what your project is doing. You can tell us about your experience mining Bitcoin. You can tell about your experience speculatively trading Bitcoin. You can ask about success story. You can, there are some really genuinely valid and very clever Bitcoin solution, even Bitcoin mining. Okay. Some of that involve setting up a factory, a Bitcoin mining operation in Iceland, right? Why Iceland? Well, energy is cheap because they have the underground energy, and also more importantly, they don't have to cool the computer. They can just open the window. Okay. Computers are like us. Okay. When you run, I don't know if any of you are runners. A few years ago, prior to COVID, and a few years prior to that, I was very much into triathlon. Well, running marathon, triathlon, swimming, whatever, requires a lot of energy. But it turns out that most of it is heat. Maybe 80% of the energy that I consume is produced as heat, not in running performance. It's a little bit like that here. Okay? It's a little bit like that here. But it's worse, because you produce heat when you do Bitcoin mining. Then you produce heat because you have to cool the computer, right? So it's double whammy, right? It's double whammy. You're not just spending a lot of energy to mine, because mining performance degrades immediately because the computer gets hot. So what do? You spend energy on air conditioner. Okay, so even if you have green energy, you're still paying for two electricity bill, right? For GPU to run your crypto mining, and for the air conditioner. Now, if you set it up in Iceland or Greenland, at least you save up the cooling bill, but still the energy bill is the same, right? So that's the story I want to take away with, and maybe instead of taking your feedback or whatever, you can think about it, right? You can certainly make counterclaims. You can say that, well, NFT is really a positive contribution to society, and it makes the world a better place. By all means, I don't mind. Okay, so it's not a homework in the sense that I can grade you on what you present. Okay, I'm going to grade you on how you think and research, regardless of what your position is. Okay, so you can come up with 5 minutes worth of why NFT is the best thing in the world. That's okay. That's okay. Okay, that's not a problem. I would disagree, but certainly you can get a full mark for that. So no more than 10 minutes. Yeah, each. Okay, but because I want your friend to interact. Ideally, it would be done in class, but see what happened with COVID. I doubt we're gonna recover that soon. So next week, it's gonna be Zoom. I'm sorry. Okay, there's nothing I can do about it. Okay,ครับ. So with that, I'll leave off. I actually have to take off fairly quickly. So hold your question, and we'll have it next class again with discussion as well, and we go to the next topic. Okay, ครับ นัดครับ